All semester we have been looking at sequences of numbers. A sequence is an ordered list of numbers. And the numbers in it are called terms. And the index is the number that indicates the order of the terms. If we're talking about a whole sequence, we usually talk about it with a capital letter. But if we're talking about the individual terms, we usually list each one of the individual terms with a small letter and a comma. Right? So here's your list of terms. Now, all of these A's are not the same, and it matters what order they come in. So we put the index number here. 1, 2, 3, 4, 5, 6, and then ... as many as you want. And then when you're getting close to the end, an minus 1, an. Now what's n and n minus 1? Well, it could be anything. In fact, this could keep going on till the end of time. This could be infinite. But if we picked anywhere and wanted to talk about it without specifically saying which number we're talking about, right? I'm thinking of a number in my sequence. I don't want to tell you what it is, but here's what I know about it already. Then we refer to it as a sub n. And the one that came before it is a sub n minus 1. Because if I'm talking about a6, the one that came before it is a sub 6 minus 1. We have talked about two kinds of sequences, and only two kinds of sequences. And so here's what happens. If that's your sequence, and you want to know what kind of sequence do I have, there are really only two flavors we've talked about. So you either have one or the other, or you have something that's neither. This is the first step in trying to figure it out. What have I got going on here? You take each one of these terms and subtract the one that came before. 25 minus 17, thank you. 33 minus 25, 41 minus 33, 8. And 49 minus 41, 8. Okay, so now you know that when we talk about subtraction, we're talking about the difference. Right? The difference between 25 and 17 is 8. The difference between 33 and 25 is 8. If these are all the same, they are called a common difference. They all have the same difference in common. If you have a sequence with a common difference, it is called an arithmetic sequence. And an arithmetic sequence represents a linear function. Going back to the stuff you've learned before, this is how all of this ties in. If you take a linear function and you look at all of the input values and then all of the output values, you'll notice that from one to the next to the next to the next, they all have a common difference. And that common difference is the slope of the line that would happen if you graphed the linear function. So all of this is all part of the same one thing. Now, the way you write what the sequence is in math words or math symbols, right? One way is called a recursive formula. And it's called recursive because of this word right here, it recurs. We're talking about what are you doing over and over and over again to make this sequence. And if you look over here at this sequence that we're talking about, you would tell me that we started with 17. That was our first term. And then you would tell me that for every term, if you want to find a term, you got to find out what the term behind it was. What was the term just before it? And add 8 to it, because that was our common difference up here. So this is called a recursive formula. This is the first term. This is the nth term. We get it by taking the one that came before it and adding 8. And that's great. That's actually how we would describe this just by looking at these numbers. It's not great if you wanted to know, well, okay, but how much will I have after 57 weeks? This is going to be way too long to figure that out. So instead, we look for some other kind of pattern. If we look here at this, we see that this 17 is just 17, but this one, that's 17 plus 8, which we already know. That's our sequence. And this one is 17 plus 8 plus 8. And this one here is 17 plus 8 plus 8, which was 33, plus 8 more. And this one here was 17 plus 8 plus 8 plus 8 plus 8 more, because that's how we build this sequence. We just keep adding 8s. Starting number was 17, and we add 8 to get the next one. Now, after you start writing this for a while, you start to realize, I don't have to write repeated addition like this. This is 8 times 1. So that makes this 17 plus 8 times 1. This is 17 plus 8 times 0. I don't have any 8s. This one here is 17 plus 8 times 2, because I got 2 8s. This one is 17 plus 8 times 3, because I got 3 of them. This one is 17 plus 8 times 4. Okay, so this is going up and up and up and up. Now, if we look at this and we see that there's a sequence here, and we look over here at the index numbers, we recognize, hey, there's like sort of a relationship here too. 1 is to 0, 2 is to 1, 3 is to 2, 4 is to 3, 5 is to 4. Basically, what's happening is we're taking this index number and subtracting 1. That's how many times we're adding it up. So that means this is going to be 17, right? If I want the nth term, right? Let's say I want the nth term, and I want to know what it is. 17 plus 8 times n minus 1, that's going to give me my nth term. Or if I wanted to write it in function notation, f of x is equal to 17 plus 8 times x minus 1. What does that mean? It means I now have an equation that will work to find out what this column has if I know what this column has. Pick a number, any number. If you subtract 1, multiply it by 8, and add 17, you'll get the number that's sitting next to it over here. And you don't have to sit with your fingers and count, okay, the first term was this, the second term was this, the 57th term was this, the 58th term was that. This is called an explicit formula because it explicitly tells you exactly what you want to know. This is going to work out the same way all the time. Different numbers, same concept. This number here is always going to be the first term. And this number here is always going to be the common difference added up 1 less than the first term. So how does that work? Well, I could say f of x is equal to the first term plus the common difference times this number less 1. Now, every time you have a situation like this, where you have a sequence and you know what the first term is, you don't want to write A1 here. You want to write 17, because you know what the number is. And you don't want to just write D here if you know that the difference is 8. Okay, here's another one. First thing to do, take 30, subtract 13. Take 47, subtract 30. Taking each term and subtracting the one that came before it. Find out what they're equal to. What's 30 minus 13? 17. 47 minus 30 is 17. 64 minus 47 is 17. 81 minus 64 is 17. We know that in this sequence there is a common difference, 17. That means it's arithmetic. We have a common difference. By definition, that means it's an arithmetic sequence. It means it's a linear function, which means if we graphed it, it would be a line. And it also means that this would be the slope of that line. If I wanted the recurring formula, the recursive formula, I would have to say two things, right? In order to give a recursive formula, you need two pieces of information. The first term is 13. And in order to get the next term or any term, you would take the term that came before it and add 17. That's the recursive. Now, let's go back here for a minute. Right? This looks familiar. And I said this is always the same thing, right? Well, it is, except that 17 is not our first number. 13 is our first number. And 8's not our common difference. 17 is. Once I've replaced all of these numbers with the new numbers, I can go over here and see, oh, look, it's the same thing. This is going to be 13 plus 17 times 0. This is going to be 13 plus 17 times 1. This is going to be 13 plus 17 times 2. This is going to be 13 plus 17 times 3. This is going to be 13 plus 17 times 4. Over and over and over again. We could go on forever. In the end, what that really means is that instead of 17 here, I have 13. And instead of 8, I have 17. And that's the explicit formula for this function. For this one, it's f of x is equal to 13 plus 17 x minus 1. All I had to do was remember the pattern that I had and recognize which numbers are going in for which numbers. I mean, I can tell you what's the same about these two, and I can tell you what's different. The same, they are each arithmetic sequences, linear functions. They each have a common difference as a sequence. What's different? Well, the first term is different, and the difference is different. If I know what the first term is and I know what the difference is, I can write the formulas for it because it's always the same pattern. And that's this. F of x is equal to the first term plus the difference times the number you're looking for minus 1. The number of the term you're looking for minus 1. Sometimes you'll get a sequence and it doesn't start with 1 over here. Maybe it'll start with 6, 7, 8, 9, 10. Well, once you find out what the common difference is, you could sit and subtract. Okay, whatever the common difference is, subtract it, I'll get the fifth term. Subtract it, I'll get the fourth term. Subtract it, I'll get the third term. That's very hard to do. There's another way you can do this. You don't have to just pick the first term every time. You could pick any term at all and add the difference times x minus the number of the term you picked. Right. The easiest way to do it, usually if you have the first term, is to do it this way. But this works too. That takes a really long time to explain. How long does it really take to do? Not very long at all. Let's take a look at this. Is this arithmetic? Let's see. 18 minus 5, that's 13. 31 minus 18, that's 13. 44 minus 31, that's 13. 57 minus 44, that's 13. And I told you could use a calculator to do this. Do the subtraction, get it done. I have a common difference. My common difference is 13. If I have a common difference, I don't have to do any more thinking. I know that I have a common difference. That makes it an arithmetic sequence. That makes it a linear function. That means that my recursive formula is the first term is equal to 5. And for every other term, you take the term that came before it and add 13, my common difference. So there's my recursive formula. Well, here's my explicit formula. It's f of x, which means I'm going to try to figure out what term I would have if I picked this number, and it's going to be equal to the first term, which is 5, plus the common difference, which is 13, times whatever number I'm looking for, minus 1. And I'm done. And in the end, that's really, once you're okay with this, that's how long it should take you to do this. So let's pick up a different sequence here. Okay? Let's pick up this one and do the same thing we were doing before. It's minus 2 minus 4. Then it's 1 minus 2. Then it's minus 0.5 minus 1. Then it's 0.25 minus 0.5. So again, I'm taking each one of these terms and subtracting the one that came before it, minus 4. So, minus 2 minus 4 is how much? Negative 6. 1 minus negative 2 is how much? Positive 3, right? Uh-oh. I don't have a common difference. I don't have to go any further to know I don't have a common difference here. So this is not an arithmetic sequence. The next thing we do, instead of subtracting, we divide. Negative 2 divided by 4. I can reduce this to negative 1 over 2. This one, 1 divided by negative 2. That's 1 divided by negative 2. Hey, got the same answer. This is negative 0.5 divided by 1. Anything divided by 1 is the same. And you've already told me this is the same number as this. 0.25 over negative 0.5. If I multiply top and bottom by 100 to get rid of the decimals, I've got 25 over minus 50. And if I simplify that, I'm going to get negative 1/2. And guess what? All 4 of those numbers are the same. These are ratios. And if I take the ratio of each term to the term that came before it, I get the same ratio. These are common ratios. If you have common ratios, that means that you have a geometric sequence. And a geometric sequence is the same as an exponential function. And if you graph this, it's not going to be a straight line. Difference. Let's go back to what we did over here. This is obviously not the same thing here, but there's a pattern that we can find that's just like this one. Because 4 is 4 times negative 1/2. How many times? Yeah, 0 times. And negative 2 is 4 times negative 1/2. 1 time. And 4 times negative 1/2 2 times is this. Now, how do I know that? Well, because that's what we just said we had. We had a starting number of 4, and then we had something where it was multiplied by negative 1/2, and then we had 4 again times negative 1/2 to get the term before it, times negative 1/2. Okay. If I want to write the recursive formula for this, it would be write down the first term. The first term is 4. And then to get any term, you take the term that came before it and multiply it by negative 1/2. That's our sequence. That's a geometric sequence because there's a common ratio. It will form an exponential function. So now, just like we know that the recursive formula is a1 equals 4, and for each one of these, for each term, you take the term that came before it and multiply it by negative 1/2. If I want the explicit formula, that's what's built in here. I'm going to take the first term, I'm going to multiply it by the common ratio. How many times? X minus 1. For the first term, I multiplied it 0 times. For the second term, I multiplied it once. For the third term, I multiplied it twice. For the xth term, I'll multiply it x minus 1 times. And that's the explicit formula. If you want to write it for just anyone, for anything at all, this is the first term, a1. This is the common ratio, whatever that is. And you raise that to the x minus 1 power. Notice that on this one, the exponent has the variable in it. And that's why they call it an exponential function. Let's look at this one. First step, negative 3 minus 6, 1.5 minus 3. Negative 3 minus 6 is negative 9, and 1.5 minus, should be minus negative 3. Right? 1.5 minus negative 3, that's going to be 4.5. And all of a sudden, I do not have an arithmetic sequence. Fine. What else can I do? Well, let's see if I can divide them. Negative 3 divided by 6, that's negative 1/2. 1.5 divided by negative 3, that's negative 1/2. As you go through each one of these, you will get negative 1/2 here. Our common ratio here is negative 1/2. I have a geometric sequence because I have a common ratio. That means it's an exponential function. That means if I want to write the recursive formula, it's a1 is equal to 6, and for each term, I take the term that came before it and multiply it by negative 1/2. And the explicit formula is f of x is equal to the first term, which was 6, times the common difference, which is negative 1/2, raised to the x minus 1 power. And I'm all done. And that's it. Those are the two sequences we've learned. They're the only two sequences we've learned. Whatever the question is, if it's a linear function, it has to have a common difference. That's the definition of an arithmetic sequence, which is what a linear function is. So if you circled linear function and common ratio, or worse, circle linear function, common ratio, and then crossed off ratio here to put the common difference, it's clear to me you don't really know. One of two things is going to happen here if you know what kind of sequence it is at this point. Either you will have a common difference because you'll subtract the terms and you'll know, in which case it's a linear function, and the common difference is whatever answer you got when you subtracted the terms, or you divide the terms, you get a common ratio, that makes it an exponential function, and when you divide the terms, you get the common ratio, and that's what you put here. And the explicit equation, well, we've already talked about what that form would be. There are other sequences, other kinds. We haven't done them yet. So for now, if you don't have either of those, you have neither. Last but not least, let's just take a look at this one, because I want you to recognize that no matter what it looks like, you do it exactly the same way. Take 5/8 and subtract 1/4. Okay. You guys know that 1/4 is the same as 2/8, so this is equal to 3/8. Take 1 and subtract 5/8. You know that 1 is equal to 8/8. Subtract 5/8, you've got 3/8. Subtract 1 and 3/8 minus 1, you got 3/8. Subtract 1 and 3/4 minus 1 and 3/8. This is 1/6/8 minus 1/3/8. Okay, so this is 14/8. 14/8 minus 11/8, and lo and behold, 3/8. So we have a common difference here. Our common difference was 3/8, which means I'm done. It's a linear function. It's a common difference. The common difference is 3/8. And when I write the explicit equation, it's going to be f of x is equal to the first term plus the common difference times x minus 1. And I'm done. It doesn't matter what the numbers are. It's all going to be the same.